So when we talk about energy in simple harmonic motion, let's give an example here where you have this mass attached to two springs. So when it's attached to two springs, in the middle we call it the equilibrium position, because here it has no energy yet until I give it as initial displacement. So I push it, let's say to the right, okay, let's say I push it to the right, and I hold it there. So when I hold it there, because I do work to push it, it gains potential energy, right? So at this point, your potential energy will be maximum, but because you're not moving, your KE is 0. So therefore, if you look at the energy, okay, later I show you the graph. Okay, so when I let go, it will start to move. So it means the potential energy will be converted into KE. So when it reaches the middle, all the potential energy has been converted into KE. So the KE is maximum, but the potential energy is 0. But then you will overshoot. If it overshoots, then your KE will be converted back into PE. So until you reach the end here and stops, then there's no more KE, there's maximum PE. So then it comes back, then your PE converted to KE. So can you see the change in energy from PE to KE to PE to KE? So there are two graphs that you need to know how to draw and how to interpret. One is energy versus displacement. Displacement means the displacement measured from the middle. One is how energy changes with time. So if you look at energy versus displacement, you'll notice that here, when the amplitude positive, when the displacement is positive x0, your potential energy is maximum, but your KE is 0. When you move to the middle, then the potential energy will drop to 0, KE will go up to maximum. Then you overshoot, your PE goes back to maximum, your KE drops back to 0. So what will happen is your PE graph will just oscillate between here, or just vary between these 2 points. Your KE will be between these two. But at all times, because energy is conserved, right, your total energy here must be the same. So there's this total energy line. So this total energy line, when you draw, you must make sure it's within these 2 points here, because this is your positive amplitude, your maximum positive displacement and maximum negative displacement. Okay, now what about energy versus time graph? So imagine we start from here, that means T is 0, you have maximum PE, which is this. So what will happen is, when you move to here, then it drops to 0. It moves to here, it goes up to maximum again. It comes back to the middle, it drops back to 0. It comes back to the starting point, it goes up here. So there's something very unique. This looks like two oscillations, right? Can you see one cycle, two cycles? But it's actually only one oscillation. So for energy versus time graph, is different from displacement time, velocity time, acceleration time. Displacement time, velocity time, and acceleration time graphs, like this, is called one oscillation. But for energy, is that these two is one oscillation. So you must be very careful, because when you interpret the period, you must take here 2 cycles here. Same thing for KE. You start from here, so your KE is 0. When you move to middle, your KE is maximum. You go to here, KE back to 0. Come back to middle, maximum again. Come back to the starting point, back to 0. So can you see it's also 2 cycles. So total energy must remain the same. That's how we interpret the graph. Understand? So what about the equations? Now unfortunately, you must know the equations, must memorize them. But it's actually not very difficult to derive it. I'll show you how to derive. Remember the formula for K is half mv squared. And the formula for velocity that is given in your data booklet is this. This one you don't have to memorize. So you take this velocity that you can get from the data booklet, you substitute inside here, and you get half m omega squared x0 squared minus x squared. So this is the formula for KE. Now to get the formula for total energy, do you realize that total energy is also the same as your maximum KE, the same as your maximum PE, right? So if I want to find my total energy, I just have to find my maximum KE lah. From this equation, at which position is your KE maximum? At which position? When x is 0. So when x is 0, you substitute x is 0 here. So this one disappears, you get half m omega squared x0 squared. So this is maximum KE, which is the same as maximum PE, which is the same as total energy. If you want to get PE, that is also quite easy, because PE plus KE is total. So your PE is total minus KE. So you take this total energy, you minus this, the half m omega squared x0 squared will cancel. Then you minus a negative of half m omega squared x squared. So these are your 3 equations: potential, total, and KE. Most of the time you'll use total, alright? But if you need the other two, you can also derive them, okay?
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.